Hello guys, welcome back to my channel. Today my topic is about photon polarization. Photon polarization is the quantum mechanical description of the classical polarized sinusoidal plane electromagnetic wave. An individual photon can be described as having right or left circular polarization or a superposition of the two. Equivalently, a photon can be described as having horizontal or vertical linear polarization, or a superposition of the two. The description of photon polarization contains many of the physical concepts and much of the mathematical machinery or more involved quantum description, such as the quantum mechanics of an electron in a potential well. Polarization is an example of a qubit degree of freedom which forms a fundamental basis for an understanding of more complicated quantum phenomena. Much of the mathematical machinery of quantum mechanics, such as Strasbourg vectors, probability, amplitudes, unitary operators, and Hermitian operators, emerge naturally from the classical Maxwell's equation in the description. The quantum polarization state vectors for the photon, for instance, is identical with the Jones vector, usually used to describe the polarization of a classical wave. Unitary operator emerged from the classical requirement of the conservation of energy of a classical wave propagating through lossless media that alter the polarization state of the wave. Hamilton operators then follow for infinitesimal transformation of a classical polarization state. Many of the implications of the mathematical machinery are easily verified experimentally. In fact, many of the experiments can be performed with polarized sunglasses lenses. The connection with quantum mechanics is made through the identification of a minimum packed size, called a photon, for energy in the electromagnetic field. The identification is based on the theories of Planck and interpretation of those theories by Einstein. The correspondence principle then allows the identification of momentum and angular momentum called spin, as well as energy with the proton. A linear filter transmits one component of a plane wave and absorbs the perpendicular component in the fact case if the filter is polarized in the x direction. The fraction of energy passing through the filter is